Yeah, Merkur Smajlaj, my name. I'm taking the role today for Lucas Renz. We're both co-founders of HydroSolid. Um, I'm the head of R&D, so chemist by background. I guess the topic of green hydrogen, green energy technologies were discussed a lot. It is part of the Green Deal, European Green Deal, to actually achieve this carbon neutrality by 2050. And we think that we are sure that this is only possible by a mix of green technologies, including hydrogen and green hydrogen for sure. Well, hydrogen can be used for a lot of use cases. Regeneration is well researched. The usage of it, such as re-electrification via fuel cells or other methods, or usage as a precursor, or gas for chemical synthesis, is also known. The storage is still a topic, as hydrogen in its normal state has a very low energy density, as it has a very low volumetric density, which is why normally hydrogen is compressed to high pressures up to 700 bar. This is the state of the art that is used in mobility, for example, and for projects in stationary or transport projects. Normally it is used up to 350 bar. Then there's also the liquid hydrogen going down to minus 253 degrees Celsius to actually liquefy the hydrogen. Topic here is that you have a high weight, you have spherical cylinders, a lot of loss actually of energy due to vaporization, boil-off effect, keeping the low temperature. It's very hard to maintain actually this, which leads also at the end of the day to high costs. Then there are the chemical hydrides, such as metal hydrides, for example, or other hydrides that are actually quite known for multiple decades now. And they are used in situations or use cases where the weight, let's say, does not play such an important role. Coming into mobility, the metal hydrides did not show, let's say, a good performance, which is why the research for hydrogen storage technologies also shifted a lot to sorption materials that are very light, have high surfaces, and can be charged reversibly very easily. This is where HydroSolid comes into play. We worked at the beginning with metal hydrides and also saw this main disadvantage of the high weight, which is why we developed an own sorption material based on a patented technology on layered sheet polymers based on carbon nitrides, something that we actually can develop in our own laboratories and fill into the tanks that we also develop by ourselves. And this is here visualization of our hydrogen storage tank with a layered material inside. The loading and unloading takes place by going to pressures up to 35 bar, which is easily achievable with actually a lot of electrolyzers. And the important part is here now, you can see on the right side here, on the loaded state, that actually the hydrogen is still bonded. This is bonded, let's say, in the matrix, but still molecularly, not as metal hydrides, for example, atomically, which makes it much easier to actually desorb the hydrogen at the end of the day and get rid of the hydrogen in the storage tank and use it for the next application, such as a fuel cell or a motor burning cell. Exactly. The sectors that we are actually aiming for are mobility, private, and industrial, which are actually all very interesting for us. And that's why we're also developing multiple products with multiple tank forms, materials that are all fit and tailored to actually these use cases. This is how our material looks like. It's a yellowish sheet polymer, which is non-toxic, non-hazardous, so it does not burn, it does not melt. It's very stable, inert, which makes it very easy for handling also. This is our product, our MVP. It's a Hive 1, first of all, for stationary storage systems. We have this, let's say, memorizing honeycomb structure, makes it easy for us to transport, to pack the tanks to a bigger amount of tanks, to a bundle actually. And it works at pressures up to 35 bar, which makes it also very easy for certification, first of all, and second of all, for handling in projects. Speaking of projects, this is one of our pilot projects in Styria, in the Sonnenscheinhütte. It is next to Leoben, next to Graz, which is actually the first alpine hut which is powered by hydrogen. And this was developed by the Alpverein Austria and us. So on the left, you can see the alpine hut with the solar panels. On the middle picture, you can see actually the electrolyzer fuel cell stacks together with, on the right side, one of our tanks. In this pilot project, we are actually also testing right now our tank for a longer time, for a longer period, to also see if it works as a seasonal storage, which makes this project very interesting for us. So it's really a prototype field testing. Second project is in Lower Austria in the sports center St. Pölten, which is also the first project in Lower Austria for this kind of project, where we have a 7.5 kilowatt electrolyzer and a 4 kilowatt fuel cell. And actually also here we have our hydrogen storage system, which can be seen on the left next to the red bundle, next to a container filled with electrolyzers and fuel cells that actually can convert the solar energy harvested on the roof of the sports center, and then re-electrify it to electricity to be used again. Also, we will announce the best startup of Austria with unicorn potential this year. This just is for us for sure a very great accomplishment, and this shows also the honor and the work that we have put into this, and also the hydrogen sector in the last 4 years in Austria. So regarding some company facts, we have a lot of partnerships for sure with metal construction companies, with upscaling companies to actually upscale also our material. We are a part of 2 European calls called Giants and Biontier, which are very much about green energy, using green materials also for this. So we are also working in different sectors for hydrogen, trying to show the importance of actually hydrogen used in projects. We also have 3 patents, one for carbon nanofibers, for the nanopolymer that we are producing, and also for our tank system, and also part of different associations of hydrogen and ESA. So I hope everything was understandable for you from my audio now. And if you have any questions, you can always contact me or Lucas Renz via mail or via phone, and also for sure ask questions now if you have any. Thank you very much.